Hi, I'm going to go over the homework problem from section 5.1. It is number 28 in the book and somewhere around 10, 11, 12 on your online homework. So you can see I put the problem up here. This is one of our expected value problems. So we've been working with the probability tables. Remember, for something to be a probability distribution, all the probabilities have to add up to 1. And everything has to be a regular probability, meaning probabilities are between 0 and 1. One application of probability distributions is this expected value. The most common applications we've seen have been either betting or with the insurance. I decided to do the example of betting. I think it's a lot more fun. If you need other examples, this is very similar to example 6 written out in your book, so you could go back and review that as well. It was also in the PowerPoint notes. I highly recommend that you set up a table, much like I've done here. So if you have an expected value problem, you're going to have a certain event that you're investigating. That's what we assign the random variable X, and that event should have a probability. There's only 2 outcomes for that event. Either you lose or you win. The total probabilities would have to add up to 1. So even if they only give you the probability of losing or of winning, you can always figure out the other one. Then the expected value is going to be the amount of money that you lose or win times the probability. Then you would add all of those up together. You can either add them up using the table on your calculator, or for something simple, when we only have 2 outcomes, we could just do it by hand. So let's look at this problem right here. I'm at a casino. My options are playing roulette. So I'm going to play roulette. That was dumping the marble in the spinning table that we saw in class. And my option is I'm either just going to put $5 bet that I'm going to land on the number 10, or I can put $5 that I get either the 000 or 1. So that seems to give me a higher likelihood because I have more probabilities. And if you know anything about Vegas, that means it's going to be a smaller payout. So the question is that worth the trade-off to me as a gambler? So I already know that for the single number, meaning if I just bet my marble lands on 10, that if I bet $5, my expected value is I'm going to lose 53 cents. So if I keep betting $5 on the number 10, playing over and over and over and over again, I will eventually expect to lose 53 cents. The question is, what's going to happen for this other game where I bet on these 3 outcomes? It seems that there should be a higher chance, and of course there is, 3 out of 38. That would make sense because those are 3 numbers out of the 38 spots on the wheel. So I've now increased my probability. So my probability of a win, I'll put in right here, is 3 over 38. And then if I win money, it tells me that I'm going to make a net profit of $15. Be really careful of reading. That's one of the trickiest things in the statistics problem, is getting through all these words. The word profit implies this is all the money that I take home. So it's true I bet $5. This probably means there's a payout of 20 and my profit is 15. So they already did the hard work for me. I can just fill in 15 in the win because I'm going to profit, meaning the money I get to keep is $15. Now, if there's a 3 out of 38 chance of me winning, that means, unfortunately, there's a 35 out of 38 chance of me losing. And if I lose my $5 bet. So that would be a minus 5 because I'm losing money. So the amount of money I lose is negative 5 because that means I'm down $5, and I've got 35 out of 38 probability. And here I would win $15. That's my profit. So that includes the fact that I had to pay $5 per bet, and I've got 3 out of 38 chance there. So I want to know my expected value. If I keep playing this game over and over and over again, consistently betting $5, what is going to be my total? We can check this as a probability distribution because certainly 35 out of 38 and 3 out of 38 equals 38 out of 38 or 1. So multiplying across, I'm just going to do this the old-fashioned way without my fancy tables since it's pretty small amounts. I only have 2 rows here. So negative 5 times 35 38ths. And that, as you can see, gives us negative 4.61. Since we're talking about money, I would round to the nearest 100. So that's going to be negative 4.61. And then to figure out what my chances of winning are, we're going to do something similar. Now I'm going to do 15 times the 3 out of 38. Oops, don't forget your parentheses there because your calculator knows order of operations. So 15 times 3 out of 38. And again, let's round to the nearest hundredth because it's money, would give me a positive 1 point. I believe that was 18. Let's check one more time. Yep, 1.18. So adding up my total from both of them, I'm going to get negative 4.61 plus 1.18. So negative 4.61 plus 1.18 gives me a total expected value of negative 3.43. So negative 3.43 goes in here. That means if I keep playing over and over, I expect to lose $3.43. Remember on the other one, so in part B, they're asking me which is better. We're assuming you want to lose less money. Unfortunately, if you're going to gamble, you're going to be losing money. So in this case, if I bet on just one number, I'm going to lose I'm going to lose 53 cents in the long run. And if I bet on three numbers, although I've got a higher likelihood of winning, it turns out I have a pretty bad outcome here. My expected value over time is $3.43. So therefore, I would choose the first bet to bet on one number because I'm losing less money, even though I'm losing in both cases.